So I'm just going to read it to you. But average rate of change is just the slope of a line. So you're familiar with finding the slope of the line between 2 points. We just did that in Matho. Average rate of change can also refer to how a non-linear function changes between 2 points. So the graph at the right is showing an exponential function. So here's your exponential function. And this line right here is drawn showing the average rate of change between x equals 1 down here and x equals 4 up here. So you can find the slope of this line. It's not a straight function, but it's showing you the rate of change between those 2 points. And then instantaneous rate of change is a new term that you're learning today, is also a slope of a line, but it's the slope of the line at only 1 point. And it tells you the rate that the graph is changing at a specific instant. So if you look here, this is a slope of a line. It's how fast the graph is changing at x equals 2. That's actually the tangent line to the graph. And so it's actually the slope is the derivative of the function. You'll learn derivatives in calculus, but we're going to get close to learning a derivative this year because we want to find the slope of that line. So how could you find the slope of a line if you only have 1 point? So here's just the 2 quick formulas for you. You don't have to write anything down on this page, but here's that slope formula that we've already reviewed. So whatever function you have, if you need to find slope, then you need to generate the x and y coordinates. So for example, what they did is they wanted to find the average rate of change between 4 and 6. So their first step was finding f of 4 and finding f of 6. So once they knew they had the coordinate 4, 49 and 6, 109, they plugged it into the slope formula and they found that the average rate of change between those 2 points was 30. This is a different function than what you saw up here. All right, so then they wanted to say, what is the instantaneous rate of change at x equals 2? So they need 2 points. So to find the 2 points, they just pick very close points. So 1.99 is very close, and 2.01 is very close. But that gives you 2 different points that way. So they did f of 1.99 and they did f of 2.01, and then they calculated the slope. So the instantaneous rate of change at 2 itself is 12. So when the coronavirus broke out, and we started looking at the number of cases in January and February, they talked about lessening the curve. So it was spreading exponentially. So you might look at instantaneous rate of change and see if that's increasing or starting to decrease day to day. If it's starting to decrease day to day, that means less people are getting new cases each day. If it's continuing to increase, then you still have that exponential function getting steeper and steeper. Does that kind of make sense? The guided practice just has you, and I'm going to do this kind of with you because I want to show you how to use the graphing calculator as a shortcut. But the average rate of change between x equals 2 and x equals 3, this is just the slope, but we need to figure out what our points are going to be. So 2 comma something and 3 comma something. So to find the y values, you just plug 2 into the function. So I'm going to do 3 squared, because 3 squared is plugging in 2. So 9 minus 5 would just give me 4. So my first coordinate on the graph is 2 comma 4. Then I'm going to plug in a 3. So 3 cubed is 27. 27 minus 5 is 22. So now I've got my 2 points and I can calculate my rate of change. It doesn't matter which point you put first, as long as you keep it consistent. So I like to put the bigger number first. So I do 22 minus 4 over 3 minus 2. So y2 minus y1 over x2 minus x1. So we can see that the average rate of change was 18. So there were 18, whatever this function is representing, but there's 18 new, cases between those 2 days. So we want to compare that rate of change 2 between 3 and 4. If this was a linear function, we'd get 18 again, because rate of change is constant for a linear function. It's the slope. But it's not if it's a different type of function. So let's see. We already know that the point is 3, 22 from the last question. So we need to plug in 4 and see what we get as our y value. So does everyone know on their calculator how to do an exponent? That little upside down caret. So 3 to the 4th power is typed in like that. 3 to the 4th power is 81. And we're subtracting 5. So 81 minus 5 would be 76. So then you would have to do y2 minus y1 over x2 minus x1 to calculate the slope. So just 76 minus 22, right? Because the denominator's 1, so 54. So if I was asking you, hey, between days 2 and 3 or between days 3 and 4, was the rate of change increasing or decreasing? Oh, the rate of change increased. So we still have that exponential function going up. It's getting steeper and steeper. We want the rate of change to start decreasing if it's a virus or something. All right, so instantaneous rate of change, I just wanted to review with you how to use the table on your calculator. So whether you're using a handheld, if there's not one under your basket, feel free to grab one from the back docs, or if you just want to use the one in your Chromebook. But I just wanted to review with you, like, I've got to grab the points 2.99 and 3.01 as my x values. So those are a little bit harder to plug in mentally, mental math. So you're either going to have to type them into the calculator longhand, or if you use the table, you can read the two solutions instantly. So on your calculator, in your y equals menu, you'd want to plug in the function 3 to the x minus 5. And you want to turn off this plot, if that plot is still on from yesterday, by just arrowing up and hitting enter will turn it off. So there's your y equals 3 raised to the x power minus 5. So we want to go into our table and be able to see the value 2.99 and 3.01. So we don't have to type it in by hand. So you go to second table setup, which is right above the window key. So second table setup. I had already plugged this in, but so you start at 3 and you count by 0.01 so that you can see on either side of that number in the table. So that's under second table setup. It's above window. And then you could just go second table, which is over graph, and it'll give you the table. You could arrow up one row. And so see how you've got the coordinates that you want, 2.99, 21.705, 3.01, 22.298. So it's easier than like typing it all in, and then you've got the 2 points right in front of you. So the 2 points I want are 21.705 and 22.298. So to do your instantaneous rate of change calculation, you're going to do same thing, y2 minus y1, x2 minus x1, and get your solution. So I'll let you type that in and someone can tell me what they get. So if someone gets the answer, feel free to say it out loud. We'll see if we get the same thing.